Welcome to the Explainer. I am so thrilled you're joining me today. I want you to think of this session as, well, a friendly mentor sit-down. If you've been stuck in what we call tutorial purgatory, that place where you just endlessly watch people code without ever actually writing your own, today is the day we break you out. We're going to dive into a foundational gateway to real software engineering, and that is building a simple calculator app. Now, I know it might sound basic at first, but trust me on this. Mastering this project is literally your first major step toward thinking like a true professional developer.
Okay, let's jump right into our roadmap for today. We're going to be covering your first real project, HTML, CSS, and JavaScript, state, events, and functions, the 4-step workflow, defensive coding and testing, and finally, how to think like a developer. Let's get to it.
Section 1. Your first real project.
Let's just acknowledge something right out of the gate. Completing a calculator app might sound like a small thing, but it is actually a massive milestone. I absolutely love this quote. The best way to learn programming isn't by watching tutorials, it's by building projects. It is just so incredibly true. You can spend days, even weeks, learning isolated concepts like variables, operators, and conditions. But until you actually put them into action, they're just abstract ideas. We're taking a super hands-on approach in this explainer because, let's face it, doing is always better than watching. You've got to get your hands dirty with real code to gain any actual confidence.
You know what's really interesting here is what hides just beneath the surface. To a normal person, a calculator is just a grid of numbers. But to a developer, it's a whole web of professional-grade programming concepts. Behind that seemingly simple interface, you've got to handle user input. You have to write functions and use operators. You have to listen for events, validate data, design a clean UI, solve logical problems, and wire up the entire application logic. This one tiny project teaches you the core mechanics that you are going to use throughout your entire software engineering career.
Section 2. HTML, CSS, and JavaScript. Deconstructing a web application into its 3 fundamental pillars is a perfect way to illustrate the separation of responsibilities. This is a huge best practice standard in web development. First up, we have our container and display screen. That's handled by HTML. HTML provides the raw structure. It dictates what actually exists on the page. Next, we have the spacing, the colors, the typography. That's all CSS. CSS dictates how things look. And yes, that definitely includes the age-old struggle of trying to center a div. Finally, the actual calculations, the real brain of the operation, are handled by JavaScript, which dictates how the application behaves. Every single piece has a highly specific job, and they collaborate seamlessly to create the final user experience.
Look, a lot of beginners make the mistake of focusing completely on the JavaScript and just ignoring the styling. But professional developers understand that UX, user experience, really matters. Good styling isn't just some nice-to-have extra feature. Having legible fonts, proper spacing, clear button visibility, and a responsive layout that actually works on mobile phones, those design choices totally dictate how users judge your software. Even a basic calculator project becomes vastly more impressive when you actually pay attention to the visual design.
Section 3. State, events, and functions.
Okay, so we've got the app looking good. Now we need to talk about its hidden brain. Let's talk about state management. This is a vital concept. State really just means remembering information during execution. Imagine this little micro scenario on your calculator. You press the number 1, then the number 0. The display shows 10. Then you press the plus button. At that exact moment, the calculator has to pause and remember that you entered a 10, and it has to remember that you want to add. Then it just waits for you to enter the second number, let's say 5. When you finally hit equals, it pulls those saved pieces of state right out of its memory, the 10, the plus, and the 5, and performs the calculation. Massive applications like social media platforms or huge e-commerce sites use this exact same fundamental concept to manage things like your shopping cart or your newsfeed.
Next up is event handling. Here's the thing. Nothing happens in your calculator until a user actually takes action. Every single time a user clicks a button, it generates an event. And JavaScript just sits there patiently listening for those user interactions. Click a number, boom, it triggers an event to update the display. Click clear, it triggers an event to reset everything. This event-driven model is basically the pulse of modern web development. It powers everything from simple, basic forms all the way up to complex, interactive animations.
When beginners start writing logic, they usually end up with super messy code. They end up repeating the exact same instructions for every single button interaction. But professional developers, they use reusable functions. They stick to a really important principle called one function, one responsibility.
So instead of copy-pasting code everywhere, you create one specific function to display number, another to select operator, and another one to calculate result. Breaking your logic down this way is a total game changer. It makes your code immensely cleaner, way easier to maintain, and a whole lot easier to read and debug.
Section 4, the 4-step workflow.
Before pro developers write a single line of code, they plan. So here's exactly how we build this chronologically. Step 1, we draft the HTML structure. We get the container, the display screen, and our raw buttons in there. Step 2, we apply the CSS styling. We center the calculator, make the buttons look good, add some nice hover effects, and ensure it's responsive. Step 3, we implement the JavaScript logic. This is where the magic happens, handling the button clicks, storing our state, and doing the math. And finally, step 4, thorough testing. We try different operations, we check edge cases, and we verify everything actually works. Remember, testing is just as important as coding. So many critical bugs are found during the testing phase, not the building phase.
Section 5. Defensive coding and testing.
All right, here is a fun plot twist for you. Users almost never behave the way developers want them to. Seriously, I want you to ask yourself right now, what happens if a user tries to divide by 0 on your calculator? Mathematically speaking, division by 0 is undefined, right? Well, if you haven't explicitly planned for this exact scenario, your application simply doesn't know what to do. It might freeze up, it might spit out some weird error code, or worse, it might crash entirely.
So the absolutely crucial point here is implementing what we call defensive programming. This means anticipating potential problems long before they ever occur. Professional software has to handle unexpected situations gracefully. So instead of letting your app crash and burn when someone divides by 0 or when they mash the equals button 10 times in a row, your code should detect that specific edge case and just display a friendly error message. Testing for these weird edge cases is what ensures your application remains completely rock solid, regardless of whatever wild inputs a user might decide to throw at it.
Section 6. Thinking like a developer.
So we've built the basic calculator, but how do we push this further? Once your basics are working flawlessly, you can really level up your app to create a standout portfolio piece. You could add decimal support. You could add an event listener for keyboard input so users can just type numbers instead of clicking them. Maybe add a toggle for dark mode, or even a sliding panel that shows their calculation history. You could introduce memory functions or advanced scientific operations like square roots. Professional developers are constantly iterating and improving their existing software through incremental upgrades exactly like these.
The real reason we care so much about this project is scaling up. The concepts you master on this simple calculator, managing state, handling events, structuring your UI, defending against errors, these are the exact same concepts used in massive, complex systems. Whether it's a weather app fetching live API data, a huge e-commerce platform managing a global shopping cart, or intense full-stack applications, it all scales up from right here. Every successful software engineer you know started by mastering these exact fundamentals. I want to leave you with this final, really important thought. You're not just creating a calculator, you're taking another step toward becoming a software developer. Growth in programming happens one single project at a time. So go ahead, open up your code editors, start building. Don't be afraid to break things, make mistakes, and fix those bugs. So what do you say? Are you ready to stop watching and start creating? Because your journey as a developer starts right here, today, with this project.
If you enjoyed this video and learned something new, like this video, comment your favorite programming language, subscribe to Future Break Coder, because many exciting coding and futuristic tech videos